What's up YouTube? It's your boy Yellow Mustang here again with another Roblox scripting tutorial. Today we're going to be going over raycasting and how it's used. So let's go ahead and jump into our script here and find out what's going on. So to start off, raycasting, you got to actually define your ray first. So we're going to do local ray equals ray.new. It's like creating a new instance. So let's actually look at the syntax here before we jump in, and the only two things it requires is an origin and direction. So the origin is going to be the starting point of where you want the ray to start at, and the direction is a vector3 value of where the ray is going and the distance of the ray itself. Okay, so if you don't know, a ray is a straight line, which is basically drawn from a point somewhere. Doesn't matter where, it's just a straight line. Okay, and that's going to be used to tell us. It's going to be used to tell us if it hits anything. It's going to give us the position of what exactly it hit. Okay, so let's do vector3 new, and we're going to have it check 100 in the air. Yeah, like that. Okay, and then to actually call the ray, let's put this in a while loop. So let's do while wait local hit and position equals workspace find part on ray with ignore list. Okay, that's going to be the one we're using today, is with the ignore list. And as you can see on here, it's listed as a tuple, meaning it returns multiple multiple values here. So it's going to return the hit and the position. This is going to be whatever part it hits. This is going to be the position of where it actually hit the part at. Okay. So the syntax here is the ray it's requiring. We define the ray here up on line 2, so that's taken care of. And then we need a table for ignore our ignore list there. Okay, and we'll jump into that in a second here. So we're gonna be kind of ignoring these two, but these are just booleans if we're gonna ignore the terrain or the water. So let's just ignore that for now, and let's continue writing this. So we're gonna go ahead and just put ray here. So that's our ray, and then the ignore table. We'll just do script.parent, so it doesn't hit us here. Okay. So this is just an anonymous table here. You can put multiple objects here as you see fit. Okay. So hold on with that. So the ignore list actually will ignore everything that is a descendant of whatever you define in the ignore list. It's not just the one part. If there's any objects within the part, it's also going to ignore that too. Multiple instances, but we'll just be using script.parent for now, and then we're going to print. So we're going to check if hit is nil or not. If it is not nil, then we're going to print the name of what we hit. Okay, so let's see what we actually got going on here in the workspace. So all we have here is this basic part, hinge on the top saying this is up, this direction. Okay, the script is actually in this gray part here, and then we got a part named boy that's anchored up above here to see if we can actually find it. So let's go ahead and run here, and let's keep an eye on our output. And forgot to put the position here. So yeah, like I said, this is the starting position. So go ahead and fix that. As you can see, it's printing boy here in the chat, because this is within the 100 studs that we defined. If we raise it up more, it stops. It's done printing boy, because it's further than 100 studs, so it's only drawing it within 100 studs. So you can also print the position. So let's actually let's give an example of how the position is here. So let's do local p equals. We'll create a part for each time it hits, and then we're going to go ahead and use the position. So that's going to set the C-frame to the position. We set the size to let's just set the size to 1 for now, I guess, and then we'll do game. And we'll give it a, let's say, 1 second delay, why not? And we're going to be creating some parts here where exactly it's hit we're gonna load some parts here where it's actually hitting on here. So you can see it's hitting here. Okay, and as you can see, it's actually hitting the parts here. They're kind of getting in the way, but you can see this is exactly where the ray is hitting there. So if we go higher up here, you can see it's actually hitting Boyle again. It's kind of switching between part and boy because the parts aren't on the ignore list, so it's hitting the parts also. Okay. So I mean that's the basics to a ray casting. I mean what you should keep note of is the direction here on the actual ray is always going to be up. Okay, it doesn't matter if this block is tilted or anything, and this, even though this side is up for the block, it's going to be going up. It's still going to be going up in the world space. However it is, doesn't matter. So let's go ahead and run this again just to demonstrate this point. Okay, and as you can see, it just still shoots the ray straight up. Okay, so now we're going to move into the part of the video where I show you an actual example of how it can be used effectively with an actual model, some food for thought, so stay tuned for that. Okay, so here's the scenario. Let's say you want to protect your civilian guys here from, let's say, a spider in this case. It's going to make it past the walls and attack your figures. Okay, so let's do something to prevent that. I got a turret pre-built here. Nothing inside of it. It's just a couple of parts here. Fairly simple. The gun is what we're actually going to be messing with here. So let's go ahead and get a script going inside of it and see what we can get going here. So let's do while, and let's get a function for find target. Local distance equals 200, local target equal nil, then for IV in pairs, workspace, get children, do, if v, so in this case we're going to be killing spiders, so let's see, if v.name equal to spider, then if, let's do, see what's inside of this spider. Humanoid, head, torso. Okay. Let's do local torso equals v, find first child, torso, and local human equals v, find first child, humanoid. Okay. So we're going to be checking the every object in workspace for the name spider, and we're going to do and torso and human. So it has to be named spider and it has to contain a torso and a human within it. Okay, so I'm going to do if, let's see, let's do local gun equals script.parent. So if gun.position, let's do a magnitude thing here. So gun.position minus torso.position dot magnitude less than dist, then we're going to do dist equals this. We're going to update the distance and we're going to set the target. So target equals torso. Okay. And that's basically that. I think that's good. Yeah. Let's do another check, and let's make sure human.health is greater than or greater than 0. There we go. And let's do return target. Okay. We'll do if find. Let's do local target, or let's do local torso equals find target. And then we'll do if torso, then. So we're gonna go ahead and find the nearest torso there, and then have the turret actually aim towards it and fire some bullets, I guess, at the torso. Let's go ahead and do if torso, then gun.cframe equals cframe.new, and we'll go ahead and have it aim. Let's do cframe.new, and we're going to do gun.position, and then torso.position, and that should make the gun face it. So let's see if this is up to speed so far. Okay, as you can see, the gun is currently aiming at the spider there. Okay, so let's go ahead and make it shoot now. Okay, let's name the script shoot. Go ahead and so have it aim, and then we'll have it do the actual shooting. So we'll do local B for bullet equals instance new part workspace b.size equals new. We'll make it how big we want it. One stud long, 0.2, 0.2. I guess that's probably size of a bullet. B.brick color brick color new. Really black. B dot. I don't know. Is there anything else we really need to do? It's probably good enough for bullet for now, huh? Okay, so let's do B dot velocity equals gun dot cframe dot look vector times 500. Or maybe that's a bit excessive. 100. Okay. I'm gonna do anonymous function here. So let's do b.touched connect function hit or object if object parent humanoid, then let's do this local human if human, then human dot health. Let's do human dot take damage. Let's do 50. Maybe too much. 35. 35 is probably alright. And then we'll do game get service debris add item B 0-second delay. Okay, that should spawn the bullet, and it should shoot now. Let's go ahead and see what happens. Okay, I forgot to actually set the C frame there. Equals gun.cframe plus vector3 new. Or probably let's do 2. So that should spawn at two studs in front of it there. A little bit off. Yeah, it's on the other axis there. Switch this to the Z act. Make this maybe 500 was proper, and we're just gonna have this go to the debris, whether or not it actually hits the spider or not. Object not gun, then it'll add it to the debris. Maybe 200 will be actually equal 2 there, but we want a 0 on here. 0.2. There we go. And that should spawn the C-frame, gun C-frame, so that should include the rotation. Okay, looks good. Let's have it do a little bit less damage. That seems a bit excessive. Do 10 damage. Okay, so you can see how this thing is shooting the wall there. So let's have it not shoot the wall or our civilians. You see this turret is was just shooting our civilian there because the spider was behind it. It also is shooting the wall there. So we don't want it to shoot the wall. So let's go ahead and put into action what we just learned there with the ray casting. Okay. So let's do another check in here. So it checks if it's in the proper distance and the health is good. So let's start our ray here. So ray equals ray.new, and so we want our starting point here. So gun.position, and then our ending point, which is going to be the torso.position. Okay, so it's going to draw a ray straight to the torso, and then we're going to actually define our hit and position and actually create the array here. So we're going to do workspace find part on ray with ignore list. Okay, so we get our ray and our ignore list in there. So we'll do ray, and we're going to include our ignore list, which is going to be torso.parent. Okay, so everything, so all the objects inside of torso. So so when it's drawing the ray, it's not going to be able to hit the torso because the head is going to be in the way of the actual line going to the torso. So as long as it's within the spider model, the torso.parent, then it's going to be ignored. So it's going to allow it to basically go straight through to the torso, if that makes sense. So you're going to see that here in a second. So let's do if not hit. If hit equals nil, then go ahead and do this. Alright, and that should be good. And let's put an else in here in case something goes wrong. So let's do else print hit.name. So you can, okay, my bad guys. So we got a bit of a mix up here in the actual array. So it's a gun.position, and then the direction in here. So we're gonna do gun, so gun dot position minus what is it, the torso dot position dot look vector, not look vector, dot unit times 500. Okay, so that should be right. So that's going to go ahead and find the actual direction that it takes for the gun to be looking at the position. Okay. So I think I got this backwards here. There we go. Okay, so now you can see. It can hit the spider now. So let's go ahead and get rid of these parts for now. I'm gonna keep this here just in case. I'm just gonna comment it out. So let's go ahead and watch this here for a minute and see if this is behaving the way it's supposed to. So you see it's hitting the part, the base, the part, the base, and there it goes. The base, Okay, I see what's happening. Let's see. Let's actually update the C-frame in here. Let's see. Let's update the C-frame. Yeah, before the ray. So that'll update, and it'll actually look at the spider anyways, even if it's not shooting there. See, I don't really understand why it keeps hitting the base like that when it's close, but whatever. Yeah, it's like when it's too close, it hits the base. And there you go, it's finally dead. Let's update this let's run this a little bit faster here, and let's see if we can increase this velocity to 500 and see what happens there, because the bullet appears to be a bit weak. So let's see. There we go. Okay, so let's see where we're actually hitting here. We'll do let's do p.canCollide equals false also, and p.size. Okay, put that 11111. We can see at least what's going on here. Let's add some more math into that. So we'll do dist equals magnitude. Hey guys, Mustang from the future here. I just want to clear up what I just went over in that code. So you could see that the parts were actually going through the spider because the ray wasn't stopping at the spider, because obviously we had the spider in the ignore list. So it wasn't going to stop at the spider, it just went straight through to the base plate when it was aiming towards the ground. So I went ahead and took the actual spider out of the ignore list, so we're not ignoring anything. And I changed our if statement a little bit here. So if the hit is within the spider model or the target model, whatever we're aiming at, as long as it's one of the pieces, the head, the arm, you know, the torso, as long as it's within the spider model, then it's going to go ahead and process this as a valid shot. If it hits anything else, then it's just going to print the hit.name. Okay, so I'll show you this in action. As you can see, it shoots the spider perfectly fine now. And the distance I went ahead and just put back to 500. It's probably a little bit excessive because we're only shooting looking for targets that are within the 200s, so we could probably even lower this to 200. But anyways, that's pretty much it. Enjoy the rest of the video. Magnitude plus 3. Okay. So let's add some parentheses in there. There we go. Okay, alright, that works a lot better. So so the ray was actually going so far as to hit behind the spider when it was looking down. So it was actually going through the spider and hitting the base behind it. So it was going too far essentially. So let's get rid of these parts now. So this appears to be working at close and far distance now. So you can see with the walls in the way, then this thing is not going to actually be an issue now. So you can see it works a lot better, and it's doesn't just shoot at the wall like some crazy piece of junk. If there's a civilian in the way, it's not going to shoot, but as soon as the spider gets into the line of sight, then it's gonna actually shoot the spider there. So let's do a little bit more with this. So let's do yeah, I guess the C-frame can be adjusted up here. I would prefer if it's adjusted down there, but this is fine. So we'll do, let's implement some tweening in here. So let's do tween equals let's see, game get service, tween service, create, do local. Alright, it's a little bit unorganized. We'll do local goals equals table, and then goals dot C-frame equals this. We'll do create. Yeah, so okay. So do gun, do tween info.new, do 0.5, and then let's see, and then we want goals. Okay. Then we would put a little weight, 0.5 in here, because it's going to take half a second to actually adjust. Let's bump this down to like 0.3. It's going to be fairly fast moving. So this will give us more of a smooth movement to the turret instead of just jumping every second there. See, now you can see this actually tweens into place very nicely. It's much more slow, much more controlled. And there you go. Spider is down, very clean. And you see it slowly rotates there. And there you go. You got a basic turret going on here now. Yeah, maybe we should make it actually make a sound when it shoots as well, huh? Let's do view toolbox. Find a laser sound. And see, oh man, yeah, as you can see. See if we can get a gunshot. Hopefully something that doesn't blow my eardrums out. That'd be nice. Okay. Oh god. Stop! Electro shot? I don't know. Roblox uploads too many songs and the search functions are so bad. It doesn't really sound like a turret. A long sound. It's horrible. Yeah, why not? Sounds good enough to me. Let's see, go in here, sound, gun, do shot. Then we do, let's go ahead and find that, local shot equals gun dot shot. And every time it actually let's see, where does it create the bullet at? Down here. So we'll go ahead and do shot play. And there you go. Whoop-de-doo. Now we're gonna do a shot here. When it shoots. Alright, and there you have it. There's our turret. Very, very nicely made, if I do say so myself. Alright. And Spider is down for the count. Alright, so I guess with that being said, and that being shown, that's how you use raycasting, and this is a real world example of raycasting being used in a game. So thank you guys for watching. Drop a like if you haven't, subscribe. We got more videos in the future. Finally got the editing software downloaded, so I'm going to start editing these videos now. It's a pain in the ass, but what are you going to do? Get that done. Alright, thank you guys for watching. See you next time.